Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. You know, for the last couple of days, we've had a look at this device, the astrolabe. Today we're going to look at its three-dimensional cousin, the Armillary sphere, which is this, and we put this together with a kit just the other day. And while you could look at it as a three-dimensional wooden puzzle, it's actually a functional astronomical instrument, and it's a three-dimensional astrolabe. So let's have a look at the Armillary sphere, how it's designed and how it's put together, and how we set it up to make astronomical observations with it. Okay, so the Armillary sphere consists of two different parts. The first part is the stand, and the second part is the Armillary sphere itself. Now, to do the initial setup, what we need to do is we need to find our latitude on the outer ring, or the meridian ring, of the Armillary sphere. This is the meridian ring. So we'll tilt this to approximately 45 degrees. Now let's identify the parts. This outer ring will be our horizon, and on the ring it has azimuths. So east would be located here, and that's 90 degrees. On the opposite side we have west. This is north at 0 degrees. And this is south at 180 degrees. This ring right here is the equator of the Earth. This is the equatorial ring of the Earth and the hour line. This part of the hour line would be approximately 6 a.m. 6 p.m. would be opposite, and up top, where our meridian ring is, this point right here would be noon. Now, looking at it from the top, we see that we have the North Star here. This is the polar circle, the Arctic circle. This ring right here is called the ecliptic of the sun. So, notice that there are dates on the ecliptic ring. For example, this would be July 10th. This spot right here, underneath our meridian, that would be June 21st. Now you'll also notice something else about the ecliptic. It's tilted in reference to our equator ring. So this is the equator, and here is the ecliptic ring. It goes up to a maximum of 23.5 degrees north. Then it comes down here to 23.5 degrees south. This would be the December or the winter solstice, whereas this would be the summer solstice or the June solstice. Where the equator and the ecliptic cross is the equinox. This is the September equinox, and on the opposite side we see the March equinox. Now, during the construction of the Armillary sphere from the kit, there are a couple of pitfalls that you can have. Let me show you the first one now. Now, when you are putting the kit together, it's very important you have things lined up properly. Now, just to give you a quick orientation, this is your horizon. This crown device here is your North Star. Directly above the horizon, at the top of the sphere, is your zenith. This is your meridian ring here. This corresponds to your longitude from your point of observation. These rings are for the June solstice and the December solstice. And in between, in these rings, we have the equinox in March and we have the equinox in September. Now, one thing that is extremely important in the construction of the Armillary sphere is when you rotate these rings, they must line up perfectly with your meridian ring. So notice when I rotate the equinox directly under the meridian ring, they're very closely aligned. However, when I rotate the summer and the winter solstice together, I want you to notice that this is slightly off. It's not quite aligned, and as a result, you can have a 1 or 2 degree error in the readings. So we just need to keep that in mind. So we have a spherical Earth that is a geocentric Earth with a celestial sphere that moves around it, but the Earth is spherical and stationary. Here is the ecliptic ring. with the dates on it. And here is the equatorial ring that has your times on it. So let's compare this to an astrolabe. Right now, I'm centered directly over the North Pole. However, if I center directly over the zenith, here is your horizon line. Here is the ecliptic of the sun. And here is your zenith. If we look at the astrolabe, we can see a similar arrangement. On the astrolabe, the central nut is the North Star. Looking a little further up, we see the ecliptic ring of the sun with the dates on it. And here in the middle, we see the zenith. So basically, if you look at it, you can kind of see how it's set up. So here is the North Star on the Armillary sphere. That's the North Star on the astrolabe. Here is the zenith on the Armillary sphere. And there is the zenith on the astrolabe. Currently, the Armillary sphere is set up for 12 noon on the summer solstice. To do that with the astrolabe, we would set the ecliptic ring to the first degree of Cancer. That's the summer solstice. And you'll see that the ecliptic is almost at the zenith. So here's the zenith. Here is the position of the sun on June 21st. Here is the zenith on the astrolabe, and here is the position of the sun on June 21st. It's very near the zenith, which is listed on the climate of the astrolabe underneath. Now, the second construction feature that I want to point out, and I've moved the Armillary sphere just simply to make it easier to see. So this is our meridian line. This is the equator line. And this is the ecliptic of the sun. Now, what I want you to notice is that in addition to the ecliptic of the sun, we also have an ecliptic of the moon. And looking at that, you see it right here. Here is the ecliptic of the sun, and here is the ecliptic of the moon. And it is offset from the ecliptic of the sun by approximately 5 degrees. Now, like the ecliptic of the sun and the equator, the ecliptic of the moon and the ecliptic of the sun are set at an angle to each other. Where they cross is called the node. If the moon is going from high to low, it's called the descending node. If it's going from low to high, it's called the ascending node. Well, the question becomes is how do you set that ecliptic properly in relationship to the ecliptic of the sun? The key to it is find your next full lunar eclipse. Now, here in Michigan, our next lunar eclipse is going to be the evening of the 16th to the 17th of May. Now, we know a couple of things about that eclipse. First of all, in order for a lunar eclipse to occur, it has to be on a night with the full moon. So we know that on May 16th and 17th, we're going to have a full moon. We also know that that full moon will be on the side opposite the sun. And we also know that it's going to be a node, because a node where the ecliptic of the moon crosses the ecliptic of the sun is the only time a lunar or a solar eclipse can occur. Looking up that May 16th lunar eclipse, we know that that is a descending node. So it's going from high to low. Let's see how we set that up properly on the Armillary sphere. Now, this is a little tricky, and the instructions on the Armillary sphere don't mention it. Right here, we have a node. And if you look at the ecliptic of the moon, it's going from below the ecliptic of the sun here to above the ecliptic of the sun here. So this would be the ascending node. Notice the symbol right here shows that that would be a new moon. And if you look at the date here, we're looking at May 16th. Now, we're set up properly so far. We're at a node. This is the ascending node. We're looking now for the full moon. The full moon will be on this side. Notice it's on the opposite side of the Earth, because in order to have a lunar eclipse, the sun has to be over here. You have to have the shadow of the Earth blocking the full moon. That's what a lunar eclipse is. So we are at a node here. We are going from above the ecliptic here to below the ecliptic here. And that means that this is a descending node. So now we have this properly set up. Okay, let's just get a quick introduction to how the armillary sphere works. We'll do a full video on this, but I just wanted to kind of show you briefly how it works. This is the location of May 16th. So if we want to find out what sunrise is on May 16th, what we have to do, here is our meridian. Here is the North Star. We've set it up for approximately 45 degrees north latitude. Here is May 16th on the ecliptic, and this is our horizon. So what we want to do is we want to rotate this so that May 16th lines up with our horizon, like so. Now, once we have this lined up, we can tell the direction to sunrise, and we can also tell the time to sunrise by reading off the timeline right here. Here's the position of the sun at dawn on the 16th. As the day goes on, we rotate the ecliptic from east to west. Here is the position of the sun at noon. And then down here, we have sunset right there. And again, we can tell the direction of sunset from here. Now, as we get into the evening and the moon rises, the sun will be down here below the horizon. The moon has come up over the horizon here, and the Earth's shadow is being cast upon the moon. As the moon rises, the full moon will pass through the shadow of the Earth. And as the evening continues and the sphere continues to rotate, it will pass out of the shadow. Just like we can determine what time sunrise is, we can also determine the angle and time of moonrise. We can also determine when the moon is lined up with the sun and blocked by the shadow of the Earth. So once again, the purpose of this video was to show you the basic setup of the armillary sphere. In our next video on the armillary sphere, we'll go through some of the functions and compare those functions to those found on the astrolabe. So until then, this is Bob the Science Guy signing out from Northern Michigan. Thank you very much for stopping by, and I'll see you again soon.